Hi YouTube, Tim Margaret here. In this video, we're going to look at the Algebra 1 Honors Finals Review. And let's look at problem 1. What is 25% of 620? So to convert from a percent to a decimal, we would move the decimal two places to the left. That would make us multiply 0.25 times 620. And when we do that out on a calculator, we get 155. Okay, so let's look at problem 2. Consider the system of equations. Y equals 2x minus 3 and x plus y equals 3. Is 1, 2 a solution to the system? So we could plug in with this first equation. We could say, does 2 equal 2 times 1 minus 3? Now, if this works, we could check the second equation and see if that one works. And if they both works, then yes, it is. But in this case, we start to work this out. We get 2 equals 2 minus 3. We know that that's not possible, right? So that doesn't work. So the answer is no. Okay, so no to that one. All right, next one, problem 3. If 36 plus m equals 50, what is the value of 2m? So we're going to solve for m by subtracting 36 from both sides. We'll do that first, and then we got to figure out what 2m is. 36 minus 36 is 0, so I'm going to cancel those out, and I get m equals 50 minus 36, which is 14. Okay, but we want 2m, so we're going to do 2 times 14 to get our solution. And that's going to be equal to 28. Okay, next one. Which set of equations is equivalent to the system 4 minus 2x equals y and 3x plus 2y equals 5? So we have 4x minus 2y equals, or 4 minus 2x equals y here. And 6, so we multiplied the first coefficient here by 2, but not the second one or the third one. So let's eliminate that equation. That's not going to work. Okay, next one we have 4 minus 2x equals y, so this is the same. 6 plus 2y equals 10. So we multiplied the coefficient here 3 by 2, but not this one. We multiplied the constant 5 by 2, but again, not this one. So nope. We still have the same equation up top. And the same equation on the bottom. So technically, this is the exact same, so I would say yes, that's equivalent. That was a bit of a trick on my part. And I was going too fast. So let's check this bottom one. Okay, so we have 4 minus 2x equals y and 6x plus 4y equals 10. So we doubled everything here. So this one also is equivalent. Didn't really mean to put two correct solutions there, but yeah, made a little bit of an error. We'll just keep going. All right, let's look at the next one. Problem 5. Which transformation will not preserve the solution set of a system of linear equations? So multiplying an entire equation by a non-zero constant, that actually will still maintain it. Adding a multiple of one equation to another, that's still going to work. Swapping the order of equations, so having the first equation be the second equation, the second equation be the first one, that should still work. But then multiplying one variable's coefficient by 0. So if you just multiply one coefficient by 0, you do change the equation. So we're going to select D. Okay, problem 6. A local craft fair features two types of handmade products, jewelry and pottery. Each piece of jewelry is sold for $80 and each piece of pottery is sold for $40. The organizers aim to sell no more than 100 pieces and make at least $5,000 in total sales from the fair. Formulate a system of inequalities to represent these conditions. So if J is the number of jewelry that we sold, plus P is the number of pottery that we sold, that's going to be less than or equal to 100 because we want no more than 100. So less than or equal to 100. And then we want the profit to be at least 5,000. So we want 80 for every jewelry item we sell, we make $80. So 80 times J is going to be the amount we make off the jewelry items. Plus, for each pottery we sell, we make 40. So 40 times however many pottery items we want or we sell. That's got to be at least $5,000. So greater than or equal to 5,000. All right, and that's our coefficient, or that's our system of inequalities for problem 6. Problem 7, we've got 3 cubed x squared times 3 to the 6th x cubed. And if we want to simplify this, well, we're going to do 3 cubed times 3 to the 6th. It's the same base, so it's going to be 3 to the 9th. And then x squared times x cubed, which is x to the 5th. Now we can actually come up with a number for 3 to the 9th if we plug that into our calculator. So 3 to the 9th, it's going to be 19,683. And that's going to be x to the 5th. All right, this next one, we got 5 cubed x to the 6th over 5 squared x squared. So this is going to simplify. We're going to subtract the exponents here. So it's going to be 5 to the 3 minus 2 power times x to the 6 minus 2 power. So 3 minus 2 is 1. So we have 5 to the 1st power times x to the 4th power. Well, 5 to the 1st power we can just write as 5. So we have 5x to the 4th power. Problem 8. All right, problem 9, a little bit more complex. We have 6 cubed x to the 5th times 6 squared x cubed on the top. So let's simplify that first. So we're going to have 6 to the 3 plus 2 power, so 6 to the 5th power times x to the 5th times x cubed is x to the 5 plus 3 power, so x to the 8th power. So that's the top, over 6 to the 4th x cubed. Okay, so we do 5 minus 4, so that's going to equal 6 to the 1st. And 8 minus 3, x to the 5th. We don't have to write the 1 there. We can just write 6x to the 5th as our solution here. Okay, next one, find all the points of intersection for this system. Show all your work. All right, so we could go hardcore and do this out. Could even do it on Desmos. So we have x minus 1 squared plus, let's just substitute in the value here for y. So plus 2x minus 5 and then minus 1, so that's going to be 2x minus 6 squared. Let's do minus 32 equals 0. Okay, so this one's going to expand to x squared minus 2x plus 1 plus this one's going to be 4x squared minus 24x plus 36 minus 32 equals 0. So let's neaten this up. So we're going to get 5x squared minus 26x 1 here, and 36 minus 32 is 4, plus 1 is 5, and that equals 0. Let's see, can we factor? So we got like 1 and 5, and we've got to pick the negative ones here, so -1 and -5. Yep, we can factor, so we want the 5 multiplied by the -5, and the -1 here multiplied by 1. So let's see, where can I write this and make it neat? Let's erase this stuff here and move it over. We're going to write this in factored form. So we're going to have 1x, or just x, and then 5x. The other side equals 0. I want the 5 to multiply by the -5, so I'm going to put x minus 5 here. And then I want the x to multiply by -1, so I'll put that here. So then we set our factors equal to 0. X minus 5 equals 0. Okay, so we're going to add 5 to both sides. So x is going to equal 5. And then y would equal 2 times 5 minus 5. So that would be 10 minus 5, or just 5. So 1 point, I'm cramming this in here, 1 point is going to be 5, 5. Okay, we also have 5x minus 1 equals 0. So add 1. These cancel. We get 5x equals 1. Divide by 5. So x equals 1/5. 2 times 1/5 minus 5 is y equals 2 times 1/5 is 2/5 minus 25/5, right? Because 5 is 25/5. So it's negative 23/5. So the other point is going to be 1/5 negative 23/5. Also negative 4.6. So 0.2, negative 4.6, and 5, 5 are our points, which you could show that in Desmos too, but it's kind of neat working it out like this. Anyways, I'm going to stop this part of the review right where it's at because the bell's about to ring, and then we'll continue on from that. If you found this helpful, please like and subscribe.